Hello, this is BAT algorithm part 2. As in part 1, we already did this algorithm. In part 1, we used another example. Now in this video, in part 2, I will use another example to show how BAT algorithm is working. So in this video, we will learn how we can compute the fitness function for each BAT, how we can calculate the velocity, frequency, position, loudness and the pulse rate for each BAT, how we can initialize the BAT population, how we can calculate the fitness value for each BAT and how we will update it. Then you can see how we can update the frequency and the position for each BAT and how we will rank the BAT according to their fitness value. So we are going to do this. As for introduction, we have BAT algorithm, what is microBAT, what is echolocation, certain rules for BAT algorithm, and what is frequency, wavelength, loudness. You can see this in the part 1 in more detail. So in this video we will focus more on example. If you want to learn the basic, then go through part 1. So you can see this. So we will try another example here for explanation. So let's see this algorithm step by step. As you know, we have more than 1,000 species of bats, and BAT algorithm is based on the echolocation behavior of the microbat. Now what is echolocation and what is microbat? Microbats are the small to medium sized bat that eat insects. Done. And they use a sonar that is called echolocation. So what is echolocation? Nothing but just a sonar used by microbats to detect their prey. Using this sonar, they can detect their prey, and you can see we have different types of bat like microbat, ghost bat, megabat. Microbats are the flying mammal, and you can see the size is small to medium and the length is 2.2 to 11 centimeter and the wing span is 25 centimeter and the weight is 3 gram to 150 gram. So as I told you, they use a sonar to detect their prey. You can see they will use a sonar, that is the echolocation, to detect their prey, and that will bounce back to microbat, and this can tell about the location, size and the information about the target to the microbat. As the pulse rate increases, it means target is closer. Done. As the bat move closer to the target, pulse rate will increase and loudness, that is the sound, will decrease. Done. So this is the BAT algorithm. First we will initialize the bat population, that is the number of bats, and we have velocity for each bat, frequency for each bat, pulse rate for each bat, and the loudness. You can see what is frequency, what is velocity, what is pulse rate, what is loudness in part 1, just a short introduction. So here we are using sound waves that BAT is using to detect the target. After that we will calculate the fitness function and we will select the minimum value as the current best solution. After that we will check the condition. If this condition is true, then we will update the frequency and the velocity for each bat. After that, if this condition is true, then we will select the best among all and we will generate a local solution around the best. Then we have this condition, then we will check. If this condition is true, then accept the solution and we will increase the pulse rate and reduce the loudness. After that, we will rank the bat and find the current best. We will repeat this loop until we got the maximum number of iteration is reached or condition is met. So first step you can see here, initialize the bat population and pulse rate, velocity, loudness and the frequency. Here X denotes the position of the bat and I is the number of bats. So for example, I'm taking here 4 microbats. So we have bat population, that is X, I is 1 to 4 and I'm using here dimension 10. So when you will apply the code according to these parameters, you will get this initial bat population. As we are using here 10 dimensions, so you can see here we have 10. So this is for the first bat, this one is for the second bat, and this one is for the third bat, fourth bat. Now we will initialize the velocity for the each bat using this MATLAB command. You can see we randomly initialize the velocity for the each microbat. So this velocity is for the first bat, second bat, third bat, and the fourth bat. Now we will initialize the A denote loudness, R denote pulse rate. So we have loudness in between 1 to 2, you can see the domain, and the pulse rate is 0 to 1. That is, maximum loudness is 2, minimum is 1, and maximum pulse rate is 1, as you can see, and the minimum is 0. So first we will initialize the pulse rate here. So for maximum is value you can take is 1 and the minimum is 0. Using this command in MATLAB, you can see we initialize the pulse rate for the each bat. This one is for first bat, second bat, third bat, and for the fourth bat. Now we will initialize the loudness for the each bat. Using this command again, you can initialize the loudness for the each bat. Here we will take the maximum loudness 2 and the minimum is 1, as you can see the domain here. So this is the loudness for the first, second, third, and fourth bat. Done. For frequency, we will take maximum 2, minimum 0, and you can see this is the equation we are using here for the initialization of the frequency. And using this is the frequency for the first bat, second bat, third bat, and the fourth bat. And we will use random numbers. As you can see in the bat algorithm, we did the comparison. So for this condition, we will use random numbers like this. So step 1 is done. We initialized position, velocity, pulse rate, loudness, and the frequency for the each bat. Now step 2 is we will compute the fitness value for the each bat. So how we can compute the fitness value? Using a objective function. You can see here we have fitness function in the meta-heuristic algorithm for the optimization, and as we already did in another videos, what is optimization? That is the optimum point where conditions are best and the most favorable. So we will compute the fitness function, and after that we will select the minimum value as the current best solution. So why we are doing optimization here? To find the best among all. And what is the objective function why we are using here? Objective function are used for the minimization or maximization of the values that you are trying to optimize. So using objective function, you can either expand, that is maximize the value, or you can minimize that value. So for this algorithm, we are using here objective function for the evaluation, that is this one. So apply this, and after that we will compute the fitness for the each bat. So when you will apply this, you can see in MATLAB you can type this command, bar is equal to sum xi square. Then for each bat you will apply this fitness function, and after that you can see we initialize the fitness. So this is the fitness value that we computed for the each bat. This one is for the first bat, for the second bat, for the third bat, and for the fourth bat. When you will put the values here, we will compute the fitness. So now next step is, you can see in step 2, calculate the fitness value. So we computed the fitness value for the each bat. Now we will select the minimum fitness value as the current best solution. So you can see here minimum fitness value is here for bat 1. So that's the current best, or you can say global best solution right now. So we have now our best solution, that is the bat number 1, and the fitness value is this. So with this, step 2 is done. Now let's see another step. Now we will update the position, velocity for the each bat. You can see we will check this condition when we will use here value for t is 1 and the maximum iteration I'm using here is 20, and this condition is true as 1 is less than 20. So we will check, we will update now frequency and the velocity for the each bat. So in order to update the frequency, we can use this equation that we already computed before. In order to update the velocity, you can use this equation, that is for the velocity update. And you can see here each bat can automatically adjust the frequency. And here, what is this current global vest position for the bat, and we are using here iteration is 1, so value for the t is 1. So in order to update the velocity for the each bat, you can use this equation, that is nothing but just this one. For simplicity, I did this. So how we can update the velocity for the each bat? We will add initial velocity plus initial position of the bat minus best bat position, and we will multiply this with initial frequency. So when you will apply this, you can see the initial velocity for the each bat that we computed and the initial position for the first bat. We will do this for the first bat, and here best bat is the first bat, and the initial frequency for the first bat we will use. That we already computed values in the previous slides. Put all these values in the MATLAB, and in MATLAB I computed this because you know we have here 10 dimensions, so in order to compute this one by one is more complex. So for simplicity I use MATLAB, and when you will put all the values for the initial velocity for the first bat and initial position of the first bat, and this is the best position, that is the first bat, and initial frequency for the first bat, when you will compute this, you can get the velocity update for the each bat. Like that we will update the position. How you can update the position? You will add some velocity that you recently computed here, like this one. We will add this velocity in the initial position of the each bat. So for each bat we will do this. We will add velocity in the initial position of the each bat, and you can see we updated the position for this each bat. This one is for first, second, third and fourth. For simplicity, you know, I'm using this MATLAB. We have 10 dimensions, so it is more complicated to do one by one. For this I'm using MATLAB. In another video that we did, so I computed the values for the each bat. As you can see here, we computed with, you can see how we computed the values for the each bat one by one. So you can see here in previous video what we did another example that is different, like a demo. So I put all the values here because this is just simple example, but this time I'm using here 10 dimensions, so it is complex to compute values for each bat for the 10 dimensions. So for simplicity I used here MATLAB. For more detail you can check how we are updating the positions here. So in MATLAB we computed this. So that's the initial bat position for the each bat. Now step 3 is done. Okay, done. Now let's see next step. Again, as we have now position, so again we will compute the fitness value for the each bat. So on this position we will use these position xi, x1, x2, x3, x4. So we will apply here again fitness function and we will compute the fitness value. So we computed the new fitness value have 6 for the first bat, for the second bat, for the third bat and for the fourth bat. So here we will apply, you can see the code here that you can write in the MATLAB. Here we will put x1, x2, x3, x4 and like that you can update the fitness for the each bat. Done. It's simple. So with this step 4 is done. Step 5. Now we will check whether the pulse rate is greater than random value that we will choose or not. If this condition is true, then we will generate the local solution around the best solution. Else we will move to next step. When the condition is not true, we will move to the next step. So you can see here the pulse rate for the first bat is here 0.4089 and the random number I'm using here is 0.1592. The condition is false. So what we will do, we will move to the next step. So step 5 is done. Now step 6 is we will check whether the random number is less than the loudness and the fitness function. We will use here fitness value that we computed is less than new fitness value. We will check here in step 6 the random number is less than loudness or not, and the fitness value that we recently computed is less than initial fitness value or not. If these two conditions are true, then we will accept the new solution, reduce loudness, increase pulse rate. You know the AND logic, how AND logic work. If both input 1 and input 2 is true, then output is true. If one input is true, another is false, then output is false. So in AND logic we need both input true, after that output is true, else it is false. So for this condition you can see we will check it for the first path. Random number we are using here 0.1592, and the loudness for the first path is 1.6714. You can see here new fitness value that we computed for the first path is 6.0645. Initial fitness value we have 11.0567. Check the condition. For this one, condition is true, this value is greater than this value, and for this condition is again true. So we have true is true. Both conditions are true, it means output is true. So condition is now true. Now we will accept the new solution and reduce loudness and increase the pulse rate. As the bat moves closer to the target, pulse rate will increase and loudness, that is the sound waves, it reduce. Done. Now we will increase the pulse rate and we will reduce the loudness, that is sound. So for this, using this equation, we can update the loudness and pulse rate. So put the value for the first bat, we have A1. For the first bat, we have loudness 1.674114 into value for alpha we are using here 0.9. We computed this, so you can see we have now new pulse rate for the first bat is 0.8357. You can see here we reduce this value. Initially we have 1.6714 and we reduce this value to this. Now we will increase the pulse rate. For this you can use this equation here. 0.001, it plays a major role, that is the step size used by the microbat. It makes a major impact on the new solution. Using this we can update it. So when you will apply this here, you can get this value, and you can see this value is greater than initial pulse rate. So we increase the pulse rate and we decrease the loudness. Now you can see we did the step number 6 is done now. Now you can see now we are going to rank the bat and we will find the current best. We will continue this loop until the maximum number of iteration is reached. So until this condition is false, we will continue the loop and then we will got the best path in the current best solution. Right now for this video I'm using just for ranking according to whatever we did in the example. According to that I will rank it. But in the program, what program will do, it will repeat the loop, this loop until condition is false. Done. So let's try this for bat number 3. Let's find out another solution. So let's check. Suppose I'm repeating the loop. So now this time we will check for the bat number 3. So check the condition. Condition is true, then generate the new local solution around the bat solution. Here the pulse rate for the third bat is 0.1371 and the random number is 0.880. Here condition is true as this value is greater than this. So when condition is true, we will generate the local solution around the bat. I'm choosing this one because for the first bat this condition is false, so we move to the next step. Now for this bat number 3, you can see the condition is true. Now we will learn how we can generate the local solution around the bat using random walk. For the random walk, as I already told you, we are using this value, that is the step size for the each bat. So in order to generate the local solution, we will use this, that is the new position of the bat is initial position plus, put the values here. This value is 0.629, 0.6294. Put the values here. I computed in again MATLAB. So we will put the initial value for the third bat, that is the initial position of the bat plus step size. Then we have this value, and the random, we are using random number, and the dimension is 1 to 10. So by this we will got new position for the third bat, that is the new solution. You can see we got this new position for the third bat, and the fitness value is now for this bat is 5.5167. Done. Now we will rank the bat and find the current best. So how we can rank the bat and how we can find the current best? For this we will check the new fitness value and the previously computed fitness value. So we will compare the fitness value. So you can see for the first bat, we will doing this for the first bat. New fitness value is 6.0645, and the minimum fitness value that we computed before is 11.0567. You can see here this condition is true. So if this condition is true, we will consider the new fitness value as the best solution. So now the new fitness value is 6.0645. As we are doing optimization, so we need minimum value. Done. You can see here this value, that is 6.0645, is better as compared to this value. So now we will consider the new fitness value as the new solution for the first bat. If this condition is not true, then we will consider the previous fitness value as the best solution. So like that, you can see we will update this for all the each bat, and we will repeat the loop until we got the new solution. And after that, according to the new fitness value that we computed, I ranked the bat. You can see the best one is third bat. You can see we have minimum fitness values here. You know, the minimum fitness value means bat is closer to the target. So according to this example, for example, according to the new fitness value, you can see the bat number 3 is closer to the target. So I ranked this according to this. So that's how this algorithm is working. So what we did in this video, first we initialized the bat population, then we will initialize the frequency, pulse rate, and the loudness for the each bat. After that, using a fitness function, that is the test function, we can compute the fitness value for the each bat, and we will select the minimum value as the current best. As we are doing optimization, so we will optimize this value, and we will check the number of iterations. If this condition is true, we will update the frequency and the velocity. Check this condition. If this condition is true, then we will generate a new solution, and if this one else, move to the next step. In the next step, if this condition is true, you know, we need true here. This is true, this is true, then output is true, then we will accept the new solution and increment. If one condition is false and one is true, then this is false. Rank the bat, and we will continue this loop. So that's how this algorithm is working. So this is just a simple algorithm. I provided all the important resources like its source code in the MATLAB files here in the description box. You know, when I'm saying about description box, again I'm repeating, as you know, user are not getting what is description box. So when I'm saying that I provided all the important link in the description box, then suppose I'm watching this video and I want to open the description box for this video. So you can see here we have so more. Done. You can see all the important links are provided here, and you can also check here. I provided the link for the optimization problem. So you can see I provided all the important link in the description box for this video also, so you can check the description box for more details. And if you have any question, you can comment below. And thanks for watching this video.